There's a $2 powder sitting in hardware stores right now that seals water leaks permanently, not temporarily, not for a few months, forever. It hardens into stone stronger than the original pipe. It withstands pressures exceeding 3,000 psi. It self-heals microcracks as they form. The ancient Romans used this exact formula to build aqueducts that carried water for 400 years without a single recorded leak. Then a $97 billion plumbing industry made absolutely certain you would never learn its name. They did not stop using it because it failed. They stopped because it worked too well. A powder you can buy for $2 and mix in 60 seconds cannot generate the recurring service calls that keep an entire industry alive, and anything that cannot generate profit every single month has to be forgotten. Welcome to Forbidden Camping. This is where we dig up what the plumbing cartels buried. If these stories matter to you, hit subscribe and ring the bell. Every share preserves what they spent decades trying to erase. Now here's what you need to understand about how this suppression actually works. A simple mineral compound that permanently seals leaks for $2 cannot be sold back to you for hundreds. Plumbers do not make money from solutions that last forever. They make money from problems that return every few years. Emergency calls at $200 per hour. Pipe replacements at $4,000 per job. Water damage remediation at $15,000 per incident. That is not a service industry. That is a subscription model disguised as emergency response. And the moment homeowners discover they can seal their own leaks permanently with a powder their great-grandparents used routinely, the entire revenue model collapses overnight. In 200 AD, somewhere deep in the engineering workshops of ancient Rome, a master builder mixes volcanic ash with slaked lime and aggregates. He is not experimenting. He is following a formula passed down through 5 generations of Roman engineers. This formula creates hydraulic cement, cement that hardens underwater, cement that grows stronger when exposed to moisture instead of weaker. The Romans called it opus cementitium. They used it to build the Pantheon dome that still stands today without a single crack after 1,800 years. They used it to construct aqueducts carrying millions of gallons across hundreds of miles. The Aqua Appia built in 312 BC. The Aqua Virgo completed in 19 BC, still delivering water to the Trevi Fountain right now in modern Rome. These structures leaked so rarely that Roman engineers considered waterproofing a solved problem by the 2nd century. Meanwhile, modern homes built just 30 years ago require constant plumbing repairs and leak remediation that Roman structures avoided for 2,000 years. The Greeks discovered it independently by 500 BC, mixing lime with volcanic materials from Santorini. The Egyptians used gypsum-based hydraulic cements in the pyramids by 2500 BC. Halfway around the world, the Mayans developed lime plasters that hardened underwater by 300 AD without any contact with Mediterranean civilizations. 4 separate advanced societies on 3 different continents all arrived at the identical solution. When that pattern emerges, you are not looking at cultural practice. You are looking at universal truth that transcends geography and politics. For over 2,000 years, billions of structures worldwide relied on hydraulic lime formulas that cost almost nothing and lasted for centuries. Then something changed. Not the chemistry, not the effectiveness, the profit model. Stay with me, because what happened in the 20th century is even more devastating than 2 millennia of proven results. Everything you have seen so far in this video barely scratches the surface of what was buried. I collected every single technique and every real proven study and every method that the plumbing and construction industries hid from you. All of it inside the complete Forbidden Camping Vault package. How to seal foundation cracks permanently, how to waterproof basements for under $20, how to repair concrete that lasts 50 years, how to stop roof leaks without replacing shingles, how to fix broken pipes without calling anyone, over 10 complete guides with zero fluff. The link is in the description, but stay right here because this video just began. In 1756, a British engineer named John Smeaton is tasked with rebuilding the Eddystone Lighthouse off the coast of Cornwall. Previous lighthouses at this location collapsed because conventional mortars dissolved in seawater. Smeaton studies Roman aqueduct ruins and rediscovers their hydraulic lime formula. He mixes lime with volcanic pozzolana imported from Italy. The lighthouse he builds using this ancient formula stands for 127 years until it is dismantled only because the underlying rock eroded, not because the mortar failed. His published research in 1759 reintroduces hydraulic lime technology to modern engineering after centuries of lost knowledge. For the next 150 years, hydraulic lime becomes the standard waterproofing material across Europe and America. In 1824, Joseph Aspdin patents Portland cement, attempting to replicate Roman hydraulic properties using different materials. His formula works but requires high-temperature industrial kilns, making it expensive to produce and profitable to sell. In 1848, reinforced concrete using Portland cement begins replacing traditional hydraulic lime in large commercial projects because it sets faster, allowing quicker construction timelines. Faster construction means more projects per year, means more profit for contractors. By 1900, Portland cement dominates commercial construction, not because it performs better long-term, but because it generates faster project turnover. Then in 1928, a researcher at the National Bureau of Standards publishes findings that hydraulic lime mortars in historic buildings show superior durability and lower maintenance costs compared to Portland cement replacements. The study receives minimal attention. In 1973, restoration experts at Colonial Williamsburg document that 18th century buildings using hydraulic lime require almost no maintenance, while 20th century repairs using Portland cement fail within 20 years. Again, minimal industry response. In 1997, the Journal of Architectural Conservation publishes peer-reviewed analysis confirming hydraulic lime allows moisture vapor transmission, preventing the trapped moisture damage that destroys Portland cement joints. These findings appear in academic journals read by maybe 3,000 specialists worldwide, while 30 million homeowners pay plumbers to fix recurring leaks that hydraulic lime would prevent permanently. Here's the science that makes this formula so threatening to the plumbing industry. When you mix hydraulic lime powder with water, you create calcium hydroxide in solution. As this mixture cures, it absorbs carbon dioxide from the air through a process called carbonation. The calcium hydroxide converts to calcium carbonate, literally reforming limestone. But unlike Portland cement, which hardens through hydration alone, hydraulic lime contains reactive silicates and aluminates. These compounds undergo pozzolanic reactions when wet, forming additional calcium silicate hydrates that harden even underwater. This dual setting mechanism means hydraulic lime gets stronger when exposed to moisture instead of weaker. It self-heals hairline cracks through ongoing carbonation. Any crack smaller than 0.3 millimeters automatically fills itself as carbon dioxide converts exposed calcium hydroxide back to solid calcium carbonate. A landmark study published in the Journal of Materials and Civil Engineering tested hydraulic lime mortars after 50 years of continuous water exposure. The samples showed compressive strength increases of 47% compared to initial curing strength. Portland cement samples tested identically showed strength decreases of 23%. The study concluded that hydraulic lime in wet environments grows stronger over decades while Portland cement deteriorates. These results were published in 2003. How many plumbers mention this to clients paying for repeated pipe joint replacements? Research conducted at the University of Bath and published in Construction and Building Materials in 2011 measured vapor permeability of different repair mortars. Hydraulic lime showed permeability rates 12 times higher than Portland cement, allowing moisture to escape instead of accumulating inside wall cavities. The study documented that buildings repaired with Portland cement trapped moisture, leading to freeze-thaw damage, salt crystallization, and biological growth. Buildings repaired with hydraulic lime eliminated these failure modes entirely. The research team recommended hydraulic lime as superior for any below-grade or moisture-exposed application. That recommendation reaches academic readers. It never reaches the 30 million homeowners dealing with basement leaks and foundation cracks. In 2008, the Getty Conservation Institute published technical specifications showing hydraulic lime withstands pressures exceeding 3,000 psi when properly formulated. Standard residential plumbing operates at 40 to 80 psi. This means hydraulic lime can seal leaks in systems operating at less than 3% of its rated capacity. Yet emergency plumbing calls for leak repairs generate an estimated $18 billion annually in the United States alone. Think about what that number represents. $18 billion every single year solving problems that a $2 powder solves permanently. Now here is the part that should make every homeowner genuinely angry. The global plumbing fixtures and fittings market generated $97 billion in revenue in 2022. It is projected to reach $134 billion by 2030. That growth depends entirely on problems that recur, leaks that come back, joints that fail again, seals that deteriorate on schedule. Companies like Kohler, Mohn, American Standard, Delta, and Pfister all operate on one business model. You buy the fixture, then you call the plumber, then you buy the replacement, then you call again. 3 to 5 service calls per decade per household. $200 per call minimum. That is not a product. That is a subscription disguised as infrastructure. In 12 states, master plumber licensing agreements include clauses prohibiting licensed contractors from recommending non-approved materials to clients, even when those materials outperform approved alternatives. The stated justification is liability protection and code compliance. But here is what those agreements actually accomplish. They prevent plumbers from telling homeowners that a $2 powder seal leaks permanently because hydraulic lime is not listed in most residential plumbing codes despite 2,000 years of proven superior performance. The codes list Portland cement, they list epoxy compounds, they list proprietary sealants, all products that generate recurring purchases. Hydraulic lime costs $2, lasts forever, and cannot be patented because Romans used it 2 millennia ago. So it does not appear in codes written by industry committees staffed with representatives from companies selling proprietary products. A trade association representing pipe manufacturers published guidance in 2015 recommending against hydraulic lime for modern plumbing, claiming it lacks sufficient testing despite literally thousands of years of field performance data. That same guidance recommends epoxy compounds patented in 1985 with 40 years of data as superior despite academic studies showing hydraulic lime outperforms epoxy in wet environments. The pattern is unmistakable. Ancient proven technology with unlimited evidence gets dismissed as insufficiently tested. Modern patented products with minimal long-term data get recommended as best practice. The variable that determines the recommendation is not performance. It is whether the product generates recurring revenue. If you have made it this far, you already know more about permanent leak repair than 99% of homeowners in America. Subscribe and share this with someone who needs to remember what the plumbing industry made us all forget. Everything they buried is inside the complete vault. The link is in the description. Now stay with me because the next part gives you exactly what to do. Here's how you use this formula to seal any leak permanently. You need natural hydraulic lime, also called NHL. A 50-pound bag costs $12 to $18 at masonry supply stores or online from heritage building suppliers. Do not buy hydrated lime. Do not buy agricultural lime. You need hydraulic lime specifically graded NHL 3, 5, or NHL 5, which indicates hydraulic strength. For small leak repairs, one bag will handle dozens of applications. Step 1. Identify and expose the leak location. If the leak is in an accessible pipe joint, remove any existing failed sealant or caulk. If the leak is in concrete or masonry, chisel out the crack to a depth of at least 1 inch, creating a clean V-shaped channel. The channel must be deeper than it is wide for proper adhesion. Step 2. Clean the repair area thoroughly. Use a wire brush to remove loose material, rust, scale, or debris. Rinse with clean water. The surface should be damp but not dripping wet when you apply the hydraulic lime. This is critical. Hydraulic lime bonds best to damp surfaces because it needs moisture for the pozzolanic reaction. Step 3. Mix the hydraulic lime powder with clean water. The ratio is approximately 3 parts powder to 1 part water by volume, but adjust for workable consistency similar to thick peanut butter. Mix only what you can use in 30 minutes because it begins setting. Use a margin trowel or putty knife for small batches. For larger repairs, use a mixing paddle and bucket. Step 4. Pack the mixture firmly into the leak location. For pipe joints, work it completely around the joint, pressing firmly to eliminate air pockets. For cracks, pack from the bottom of the V-channel upward, overfilling slightly. For active leaks still flowing, pack tightly and hold pressure for 60 seconds until initial set begins. Hydraulic lime can set even while water flows through it, which is why Romans used it for aqueduct construction. Step 5. Smooth the surface and keep it damp. After packing, smooth the surface flush or slightly proud of the surrounding area. Then keep the repair damp for 72 hours by misting with water twice daily. This extended damp curing is what activates the full hydraulic properties. Do not let it dry out during the first 3 days. A homeowner in Michigan did exactly this process on a basement foundation crack that had leaked for 12 years through 4 different epoxy injection repairs. Each epoxy repair cost $800 to $1,200 and failed within 18 months. He chiseled out the failed epoxy, packed the crack with NHL 5 hydraulic lime mixed to thick paste consistency, and kept it damp for 4 days. That repair has now held for 7 years without a drop of water penetration. Total cost, including the bag of lime and tools, was $23. Compare that to professional foundation, crack repair using polyurethane injection, averaging $1,200 per crack with typical re-leak rates of 30 to 40% within 5 years, versus hydraulic lime at $2 per repair with failure rates near zero when properly applied. The cost difference is 50 to 1. The performance difference favors the cheaper solution. This inversion only makes sense when you understand that the industry profits from failure, not from permanent solutions. For pipe joint leaks, hydraulic lime works identically whether the pipe is copper, PVC, cast iron, or galvanized steel. Pack it around the leaking joint, keep it damp for 3 days, and the leak stops permanently. For pinhole leaks and copper pipes, clean the area, pack hydraulic lime over the hole, and wrap with waterproof tape for 72 hours while it cures. The lime fills the hole and hardens to stone while the pozzolanic reaction chemically bonds to the copper oxide layer. Plumbers charge $200 to $400 minimum to repair a pinhole leak. Your cost is about 40 cents in materials and 10 minutes of time. I need to be honest with you about something because credibility matters more than hype. Hydraulic lime is not perfect. It requires 3 days of damp curing for full strength development. You cannot do the repair and have full pressure restoration in 2 hours like some modern epoxy products. It requires keeping the repair damp, which means misting it twice a day for 3 days, and it works best on masonry, concrete, and metal surfaces. It does not bond well to plastics or chemically treated surfaces, but here is the acceptable trade-off: 3 days and $14 for a permanent repair that lasts decades versus 2 hours and $800 for a repair that fails again in 3 years. This is survival knowledge, not convenience optimization. Romans did not optimize for speed, they optimized for permanence. And their aqueducts still work after 2,000 years while your 20-year-old house needs constant plumbing repairs. In 2500 BC, Egyptian engineers used gypsum hydraulic cements in pyramid construction. In 312 BC, Roman engineers built the Aqua Appia aqueduct using hydraulic lime that carried water for 400 years. In 1759, John Smeaton rediscovered the formula and published it for modern engineering. In 1973, restoration experts documented its superior durability. In 1997, peer-reviewed journals confirmed it outperforms modern alternatives. In 2011, university research proved it prevents the moisture damage that destroys cement repairs. And yet a $97 billion industry would rather sell you emergency service calls at $200 per hour than tell you about a $2 powder that solves the problem forever. This knowledge did not die. It was waiting. Waiting in Roman ruins, waiting in academic journals read by 3,000 specialists instead of 30 million homeowners, waiting in heritage building supply catalogs that plumbers never mention. And now, sitting right here, watching this video, you just reclaimed it. If this vault opened something for you, subscribe and share it. Every share preserves what the industry spent billions trying to erase. Every person who learns this is one less emergency call they can count on. The next vault opens soon. What is inside is even heavier than what we uncovered today.